I'm sure you know how important water is to our everyday life. But since we're so familiar with water, we sort of take its properties for granted. But from a chemical perspective, water is very, very unusual. Some of the four properties that we'll be focusing on that distinguish water from many other substances include the fact that liquid water is denser than solid water, known as ice. Water has an unusually high boiling point, which allows it to exist as a liquid at room temperature. Water also has a large capacity for absorbing heat before it changes its temperature. And when water goes from the liquid to the gas phase, whether we're talking about boiling or evaporation, a lot of heat is required. Water is essential for life as we know it. Most organisms are comprised mostly of water because most cells are comprised mostly of water. And the ability of water to dissolve a wide range of substances such as glucose or potassium or sodium ions allow for the cells to engage in life-sustaining processes. So let's look at some of the special properties of water. On this slide, we see three molecules, water, ammonia, and methane, and also their ball and stick structures are drawn as well. Generally, boiling points of a substance depend on its molecular weight. Water, ammonia, and methane have very similar molecular weights. However, when we look at the boiling point of water at 100 degrees Celsius, it is way higher than that of ammonia at negative 33 degrees Celsius and methane negative 161 degrees Celsius. Water should be a gas at room temperature, like ammonia and methane are, and we'll learn later why it isn't. One of the important things about the features of water that we need to remember is its geometry. We've looked at the geometry of water already, but here's a reminder. On the slide, we see a graphic or a model of the water molecule, and you may remember that oxygen fulfills the octet rule, and it has 4 electron pairs around it. Two bonding pairs for a total of 4, and then 2 lone pairs. So 4 plus 4 is 8. Often these lone pairs are not drawn, but chemists know that they're there, and they repel. So since oxygen has 4 electron pairs around it, those electron pairs repel each other in approximately angles of 109.5. But since the lone pairs are better able to repel, this oxygen-hydrogen bond angle is less than 109.5 and is approximately 105 degrees. So the upshot, or the main idea here, is that water is a bent molecule. If water was linear, its properties would be completely different. So you want to remember the structure of water. It's a bent molecule.